Okay, we're ready to go. Well, tonight Jerry is going to finish up chapter 5, components, parts is parts, and then I'll start on chapter 6, communicating, and we got some good stuff. So Jerry, take it away, my man.
Take it away. Okay, let's see where it went. Um, okay, Dump. And um, okay, where's my tech module 5? Okay, good. Now I can, if I can find my screen again, I will start sharing. Okay. Okay, well, you probably have seen this last week. Well, first of all, are there any questions about anything we've done so far, or something that's just on your mind right now? Good, everybody knows everything. Yay.
Hey, even I don't know everything.
After 60 odd years in the hobby, all I can say is that I know more than some, but less than others. So you're always going to find somebody who's a little more expert than you. Okay. All right, we talked about different kinds of radios that you're going to encounter. These two, the handheld and the dual bands, are ones that are most prized by technicians. It's their sort of entryway into ham radio as it is. With the handhelds, you can get into ham radio. You can start using repeaters. Fairly short range. If you have one of those 5/8 wave antennas that I talked about last week, you could probably get up to 3 miles range. And remember that the higher the antenna, the better off you are, the more range. And if you have a microphone, clip this handheld to your belt, and you have a microphone, your antenna is only going to be about 3 feet above the ground. So keep that in mind. Single band and dual band FM radios, usually for 2 meters on 144 to 148, and 70. The second option is 70 centimeters. And they're usually in the area of 25 to 75 watts. They get out farther. You see they're a lot bigger, so they're suitable for sticking in your car. And they get out farther. The extra power helps. You can see that these keyboards have all sorts of functions. One of the main functions is selecting frequency, but it can also select different kinds of subaudible frequencies, so you can get into various repeaters. Multiband, all mode, I guess they call it, is something that will do either all of the VHF, UHF frequencies, and they'll do single sideband, AM, FM, CW, and because they have the single sideband in there, they cost more. The Bobson FT991A is a very good example of that, because it does HF from 1.8 megahertz all the way up to 440, all in one box, and it does sideband, FM, AM, and CW, and data. Okay. So All right, one thing that some people ask about, let's see if I can get this down. All right, what if you want to do other frequencies? For instance, there's some active ham bands on 1296 megahertz. Well, they have a box called a transverter, which is our old friend, the mixer. What it does, it takes 1296 megahertz and mixes it with 1152. So 1296 minus 1152 is what, 148? No, 144. So what it'll do, it'll take the 1296 and convert it down to 2 meters. So you can use your HT, for instance, to receive and also to transmit. The transverter will do the same thing. Here's the, you connect the HT or whatever kind of radio you have here. And depending on the, here, this will be almost transmit and so on, transmit and receive. So that'll do the job for you. And they have some for different bands. As I've told you often before, there isn't any problem that we can't face and solve by throwing money at it. So all right.
If you were highlighting stuff on your screen or pointing stuff out, we didn't see anything. It was still in the handheld dual band multi-band
Ooh,
view for us.
oh, I am
I
sorry.
agree.
Okay, well, let's get back there. Let's see if I can find it. All right, I'm going to stop sharing and start share again. Okay. That better?
Yes.
Okay. Right. Transverter. That's what it is. You can use go to higher bands. There are transverters that will get you up to 10,000 megahertz. And actually, there's a quite a bit of a following of guys going to high places, mountain tops and stuff, trying to get as much distance as possible. I think they've gotten a few hundred miles, if I'm not mistaken, Bob. Okay, questions on this? All right, let's
Jerry, what does something like that cost? Is that expensive?
Yes.
Oh, okay.
I didn't really look at the price. I could, I guess. What's the model number? Well, it's got a. Looks like they did some engineering on this.
That's
thing.
okay. I can pop out and see if I can get it. That's I'll get back with you.
Okay, but anyway, there are a number of people who are making these things. Some of them are making them in their garages, and if they get big enough, they'll do a little better. Okay, all right. Let's go back to this guy. All right, I'm going to there's my come on. Let's stop sharing. Okay. All right, we'll go back to out of the transfer and back to my. There we go. Okay. Okay. Everybody see this now?
Yeah, we were back to the sample radios.
Yeah, sample radios. Okay. Control the frequency and mode, that's all radios have that. The ones you get, the HTs and the mobiles usually don't have very much change in mode, although some of them have a receive mode, like this guy is my little Yaesu VX5. It's actually goes from I think the AM broadcast bands, 550, all the way up to about 18 megahertz AM. It'll do FM broadcast as well as the ham modes. And it'll switch back to AM if you want to look at the aircraft band around 108 to 136, I think it is. And then go back to FM for some of the other stuff. I was able to listen to taxi cabs and stuff like that on this thing. So this does have AM and FM in it. You can't transmit AM on these things. I don't know why you would want to. Okay. There are memories. That little thing I have had something like 200 memory channels. Others have up to 2,000. I think those Wujan and Baofengs have an amazing amount. So you can put stuff into a memory, and if you have say 50 or 60 different repeaters in there, you can actually have the computer inside the radio scan all of those channels, all those memory channels, listen and see if anyone's talking on it. And when it detects an active channel, someone talking on it, it stops and for a little bit so you can hear, and maybe if you want, you can jump in and talk to people. Okay. Right. Transmitter output power. All of these radios have a different way of varying the power. This thing, well, I bought it in 2004. It has 5 watts output, but you can put it down to less than a watt if you want. That's I'll use the minimum amount of power to make your communications, and also not to overload the receiver on a repeater if you're too close. For instance, if I go about a mile down the road, I come to the Hazel Park Amateur Radio Club's repeater, and I certainly don't want to shoot 5 watts or in the mobile 50 watts into it, because it'll make the receiver a lot less sensitive to farther off stations. So I can reduce the power. Okay. We talked about push to talk and voice operated Vox. I would make sure that I don't have this. Okay. Make sure I don't have it on, but I can just, yeah, this is W9NP, and it'll automatically switch. Or if you have, just the radio that comes with it, ICOM radio. little switch on the side. And push to talk. This thing doesn't have a whole bunch of settings. Well, this is an HF transceiver. Doesn't have a whole bunch of settings, although it does have a couple of buttons on the top that can be programmed to almost anything. When I first got this, I was using it, and I tapped this, and it was set to change the frequency. So I transmit, and maybe my thumb would hit it or something of that sort, and I'm on a different frequency. I couldn't hear the guy I was talking to. So you can program that. I actually neutralized it, and then I got a much more sophisticated headset. All right. Okay. Okay, we talked about splatter last and overmodulation, over deviating last week. All right, receiver volume control. It sets the speaker or headphone level. Now, the receiver has two controls, a volume control and a sensitivity control. It's called RF gain. Automatic gain control means that it will automatically set all the stations at a certain level. So you don't have a very weak signal and then a very strong signal overloading you. Squelch. Okay, squelch will quiet the receiver. It'll actually turn off the audio until a station comes up. And let's see, I don't see anything here right now. Now, squelch is usually preset in a handy talkie or a mobile. The other radios have a special dial that you can set the squelch. If you set the squelch too high, it's not going to turn on when a weaker signal goes on. So I have to worry about that. Okay. Selectivity and sensitivity. Sensitivity is the ability to detect signals. Selectivity is the ability to separate out signals. All right, let's see if I can find something. Unfortunately, the band is starting to. Okay, now the ability to filter out interfering signals. Okay, what that does is narrow the amount of the frequency that it's the receiver sees. And it's very handy if you have a lot of stations on, if there's a contest or something of that sort. A lot of this is now done by software. The biggest plus I think we've found is in computer sound cards, because they do what took an awful lot of money and research to do back in the old days to be able to separate frequencies. They had things like crystal filters and mechanical filters that were made by Collins, the Mercedes of the companies. And these current, much cheaper radios just run rings around them. Okay. Preamp is a stage that boosts sensitivity. If a receiver is not sensitive enough, you can either attach a preamp or buy a radio. This one has two preamps in it, so I can switch in. I can either use no preamp, preamp 1 or preamp 2. Okay. Filtering. Okay. Wide filter. Okay, these are the questions. Wide filters around 2.4 kilohertz or 2500, I think is the question. Narrow filters for CW. And there's, okay, receiver incremental tuning. It's a fine-tuned control for sideband or code. Let's see if I can get that. And also, what happens with the receiver incremental tuning? There's an auxiliary function that's called split frequency operation. That's where you're transmitting on one frequency and receiving on another. It happens more often than you think, especially if you're on the HF bands and listening to a rare station that with a lot of people calling him. He wants to have his channel in the clear, his transmitted signal in the clear. So he will usually say, all right, I'm listening up 5 or listening up, which means that you set your transmitter to transmit a few kilohertz higher than him. And there are ways of monitoring where your transmitted signal is. You can just push a button and it'll tell you where you're transmitting. And sometimes, if you're lucky, you'll get the guy that the DX station talked to last. And if you're on the same frequency as that guy, you can just zip in and maybe he'll hear you. Power amplifiers, again, throw money at it and it's yours. But make sure your antenna is capable of handling it, because a lot of the stuff that's being sold by the stores now are capable of handling about 150 watts or thereabouts. So make sure that the antenna is built to handle the 500 or 1,000 watts that you're doing. Bob, you don't have an SB200, do you?
No, I do not.
Okay. Back in the dawn of time, a company called Heathkit, a lot of people at the time called them grief kits, would assemble kits, or they'd send out kits for you, wonderful instructions, and you'd build it yourself. It had an amplifier, I think about 100 watts from your transceiver in, and up to 1,000 watts. Well, can't call it output; it was input power at that time. But anyway, you'd have a very significant amplification, and that stuff would burn out. If you're using 300 ohm twin lead, probably burn that out. So you'd have to make sure that your antenna can handle it. All right, chapter 9, RF exposure. You'll get into that. Luckily, we don't have hard radiation like that little pea-sized piece of radioactive cesium, I think, that was lost in Australia. Okay, transference, we did that. Let's see, no practice questions. We're going to try to go back into harder stuff. Okay. Digital communications. I think we talked about a little bit where you can use a low power, and with the digital modes, you can actually be received by a computer connected to the radio. And they also do error correction. I'm going to talk number one about. Well, I'm going to pick up a couple of modes and have you listen to them. All right. Let's see. Art. Where's ready? Radio. Okay. Radio teletype is teletype was an old mechanical type of typewriter that was put on telephone lines and was used ever since I guess stock tickers, which were the great granddaddies of these things since about the 1870s or thereabouts. By putting them on the radio, it used two different kinds of pulses. So two different frequencies were used. And the radio teletype signal would sound something like this.
Can't hear anything.
Can't hear anything? Well, let's try it again. Anyone?
No, not yet.
Oh,
Nope.
let me, okay, I'll tell you what, I will stop sharing then, and maybe that'll do it. Okay. How's that?
Jerry, do you have it up to your microphone?
Yeah,
That's the camera, isn't it? There's a mic right next to it.
microphone's in it.
I didn't hear it.
No one?
No.
That's beautiful. Okay. I guess I can't share that with you. But what it is, it's two different tones, and one is called Mark, one is Space, and they're doing like that in different combinations to make up the letters of the alphabet and numbers and bells and whistles and things of that sort.
Is this what you're talking about for teletype?
What's that? I heard a buzz, but that was about it. RTTY?
Yeah, I found a YouTube video of it and it should have been pushing out right.
Well, blame it on Zoom. Okay,
Was that it?
no,
Brad, we're not hearing it. That's funny.
It must be,
wonder if-
yeah, it must be Zoom not picking it up right
Yeah, I
because
wonder
of
if,
how it's
it's-
pushing.
can anyone hear this one?
Filtering it out. Nothing.
I heard a
nothing.
chime.
That was my computer.
Okay. And that's weird because I was
Very-
pushing it straight in as if it was a microphone going into.
Oh, this is very disappointing because I thought we were, I thought we just did that.
That's odd. That's so odd.
I have, let me, what,
Okay,
I was pushing it into Zoom with an audio cable, just like my microphone is pushed in through with an audio cable.
well, the thing is, the audio is coming from my mouth into the microphone and you can hear it.
Yeah.
It's coming, coming out of a loudspeaker in my radio, and you don't seem to be hearing it. Let me try one other thing.
Maybe there are
Yeah.
filters in the Zoom codecs that limit out that kind of content.
Has to be, because I was pushing it as if it was coming straight from like it was a microphone itself, and essentially.
Right.
I've got mixer boards installed and I use mixers for everything.
All right, well, I guess we can't do it. But anyway, there are different ways of digitizing the radio. And what generally happens is the computer will pick up the signal, even where a human ear can't. It'll pick it up below the noise level. Joe Taylor, K1JT, is I guess one of a few ham radio Nobel Prize winners, and he came up with a whole suite of different kinds of digital signals. Some are used for bouncing off the moon. Some are used for very weak signal type stuff. I think I told you the story about a ham in Australia attaching a GPS to a very small transmitter and tying it to a Mylar party balloon. And it went from Australia through the Pacific, across the tip of South America, across the Atlantic. Yeah, well, we heard something. But anyway, the balloon ended up in Madagascar, and there were people all over the world who were tracking it as it went, using this weak signal type of thing. FT8 is the current very, very popular way of sending signals that way. And even with bad antennas, you can use FT8 to make long distance contacts. So that's a terrific thing. Okay, one last thing, I guess. I'll share.
Jerry, can I ask you one thing?
Yeah.
Can you hear that?
Yes.
You can hear that?
Yes,
Yes.
Yes.
All right. Is that ready?
Nope.
Oh, okay.
I don't know what that is. Well, I could, let's see, where's my okay, I'm going to stop share, reshare. Wait, that almost sounded like Riddy. That's it. It's fairly high speed, and you can hear two tones. And
Hello.
might be sound of FT8. Okay. Music for the ionosphere, sound of FT8. Can you hear that?
no,
I can't hear nothing.
No.
No.
Hang on. I'll stop share, start share again. And where did it go? No?
Nothing.
Okay. I guess there's more work, more mysteries of FT8.
You hear that?
Nope. All right, another troubleshooting project, I guess.
Huh.
Okay. Let's see. They had a couple of other things that we don't use that much of anymore. Okay. Let's see. APRS, which actually I had one occasion to see APRS in action, and uses a GPS and is a way of watching someone as he travels, or if you're a net control station and are waiting for, want to know where your units are. And each of the unit has an APRS system. You can put up a map and you know where everyone is. And my only experience with it is I was watching a guy go from his motel in Miami up to a restaurant in North Miami. And I was thrilled. Okay. All right. Okay, so gateway is a way of getting into the internet. Repeaters will usually, a lot of repeaters, including our Hazel Park repeater, has a gateway. So you can load a repeater directory. Go to the very back of the repeater directory. Let's see, is it in focus? No. Anyway, it's got a bunch of nodes for different locations around the world. For instance, if you want to contact well, Troy, New York, you punch 428054 on your microphone or on your handy talkie, and the data interface will dump you using your handy talkie will dump you into New York City. Or I think if you hit what is it, the London, England, I think it is. Oh, this is all national. So anyway, so there's a way of using the internet. If things hit the fan, don't depend on the internet though. So I think that's pretty much the deal.
Jerry,
Yeah,
I don't know if this is on the same topic or not, but somebody was saying that there's ham radio called SDR radio. I guess it's on your computer. Does that allow you to listen to everything that we usually be listening to, or instead of buying
okay, SDR.
channels to learn?
Right, ST, actually, most of the radios that are being sold now are mostly SDR. They're software-defined radios. And I'm glad you asked that, because there's the computer actually controls the radio. And well, let's get out of this and I'll get into. There it goes. Okay, everybody see this?
Yes.
Yes.
Except for the fact that it's not showing my this is kind of strange because it's not showing my all of this display. Let's-
Oh, the waterfall display, yeah. It's
well,
not,
it won't show waterfall display, but it'll show other stuff. Well, it's
So I was playing with this before I knew what this was. There's actually a couple softwares you can download on an Android phone and a dongle you can get on Amazon to
Yeah.
turn any Android phone into an SDR.
okay. This is supposed to be receiving. Okay. And that's not operating the way I like it either.
yeah, it looks like you've got it set for CW.
I got it set for CW.
Okay.
So I have a question about CW.
Here,
Is there a way to change the pitch of the beeps when you hear them, or is that just how it is?
like this. Oh, you can't hear it. Yes. You change the frequency on the dial
Okay.
or use the what they call a clarifier.
Because my issue is I spent like 9 years around helicopters a lot.
Yeah.
When I was in the Army, and quite a few times refueling them with blades spinning. So I can't always distinguish a short beep from a long beep when I'm listening to CW.
Well, it depends on, yeah, it depends on the frequency and most of the transceivers on HF have a pitch adjustment for listening to the transmitted signal or your own keystrokes. So you can adjust that, and you can use receiver incremental tuning to adjust the sound. Not well, you don't even have to use the RAT for that. If you adjust the pitch on the, for instance, let's get this. Nobody can hear that?
No.
Dang. Bob, maybe you'll have to use yours. You have a J38 on your, and anyway, if you adjust the pitch on your transceiver to something that you can hear when you send, then when you hear another station on that same with that same pitch, you know that he's directly on your frequency. So yes, it's adjustable.
Okay.
Okay. All right, batteries. I don't know what will we say about batteries. We know about chargeable and rechargeable batteries, or unchargeable. If you try to charge an alkaline or a zinc type battery, you're going to come to grief. And other than that, what is that new one that they just came out with? Something PIFO4 or something like that. It's they're getting better and better. And as far as size, as far as being able to give you enough currents to run a battery operated portable or some such. People used to use the was it a FT 817 or 18 transceiver. They were small lights, and you could carry enough batteries on your back to power the thing all day when you wanted to visit your local mountaintop. So it's getting better and better. And power supplies always get more than you think you need. Most of the transceivers, the HF transceivers, are going to require 20 to 25 amps. A 50 watts mobile will require something like 15 amps. And the power supplies are also going down in price. And for probably around 100 to 125, you can get a 25 amp power supply. So that'll be a very nice thing. Okay, Bob, I hope I didn't take too much of your time. Go ahead.
No, we're fine. We're fine. And, but chapter 5 is important, so, you need to take the time it takes, and that's the way it goes. So let me fashion this in a little bit. All right, we're going to have some fun. But first, let's look at this. Wait a minute. I forgot to share. Okay. Now, everyone can see that slide?
Yep.
Yes.
Yeah, okay. All right.
Yes.
Now, chapters 1 through 5, we've had some really, really interesting stuff, and some of it's been pretty technical. I really like the way Jerry describes the whole technician pool of information you need. He's always described it as the subject matter is a mile wide, but only 1 inch deep. But still, in the first 5 chapters, there's some heavy, weighty stuff. Now we're going into a different type of subject matter. And let me tell you, it's easier. It's not as cool, maybe. It's not as sexy as learning about electricity or radio waves or radio signals and equipment, but it's stuff you need to know. And this is going to be stuff like chapter 6. We're going to talk about operating procedures. Next week and the week after, Mike is going to be talking about chapter 7 and chapter 8. Chapter 7 is rules and regs, and it's important stuff. What I want to show you here is, you notice in the second from the right, the column second from the right, your test is going to be composed of 35 questions. And what I want to show you is that the subject matter in the next 4 chapters, which is relatively easier than everything that we've done up to this point, comes from the column on the far right. So what you see is that under FCC rules and descriptions and operator and station license responsibilities, a total of 6 of your 35 questions can come from that. For operating procedures, what we're going to talk about tonight, 3 questions can come from that. From amateur radio practices, which we're kind of going to get to a little bit, and station setup, Jerry talked about more, but still a couple of questions there. You go down to element 8, modulation modes, amateur satellite operations. We're going to talk a little bit about satellites tonight. Operating activities we're going to talk about. We're going to talk a little bit about digital, although Jerry covered that also, but you see there's 4 questions in that. And then in safety, in RF hazards and some other stuff, there could be another 3 questions. What I wanted to get to you is that there's a total for the next 4 chapters are going to produce somewhere between 15 and 18 of the 35 questions that you're going to have on the exam. And what I want to do, what Mike and I want to do on these next 4 chapters is we want to get you to a place where on this easier material, you're going to walk in and you're going to ace them. You're going to get these 18 questions completely right. And you should. It'll take a little work on your part. We're going to try and get you a lot of review and answer your questions and whatnot. But 18 questions, and you think about it, if you can walk into the exam and you know that you've got 18 of the 35 questions correct, that leaves you with 17 questions, of which you can miss 9. So, because you've got to answer 26 or 27 questions right. So you'll have a lot of leeway. So for those of you who may have been a little less confident on some of the more sciencey, technical stuff that we've had, these next 4 chapters will be easy for you, and it will give you a leg up when you get to the exam. Okay, so without further ado, let's kind of get into it. But before we do, I just want to review one thing, because, oh, damn it. Hang on. Okay. Let me make that just a little smaller. Okay. All right. Now we're going to be talking about different bands tonight a little bit. And I just want to review that when we're talking about VHF, we're talking about 30 megahertz to 300 megahertz, this range right here. And when we're talking about UHF, we're talking about 300 megahertz to 3000 megahertz, which is also 3 gigahertz. So that's that. I don't think we're going to be talking much about HF or the shortwave bands, the 3 megahertz to 30 megahertz, but these VHF and UHF, remember what those are, okay? 30 megahertz to 300 and 300 megahertz to 3000 or 3 gigahertz. We talk, and there's actually some questions about actual frequencies. One of the questions in there asks about the frequency range for the VHF calling frequency, and the multiple choices you're going to have. Two of the multiple choices are not even in the VHF range, right? VHF, and specifically they're talking about the calling frequency on the 2 meter band, and 2 meter is going to be, well, we always talk about it being 144 megahertz to 148 megahertz, but if you forget that, then remember this formula we told you about. You've got 300, okay? And if you know that you need to know the approximate frequency of the 2 meter band. The 2 meters is the wavelength, the lambda, the 2 meters. You divide the 2 into the 300, and that's going to give you an answer of 150. All right, so 150. The VHF band is going to be somewhere, or the 2 meter band is going to be somewhere in a 150 megahertz range. It's actually 144 to 148. But it's close, and that's all that this little formula can give you. You know where it works best? It works best for the 6-meter band, because think about it. The 6-meter band, okay, you take the wavelength 6 and divide it into 300, and that's going to give you an answer of 50. And as it turns out, the 6-meter band begins at exactly 50 megahertz. Okay, does everyone understand this? What that 300 is, we're dealing here in megahertz, frequencies of megahertz, which is millions. The 300, of course, is referring to the speed of light, the 300 million meters per second. Okay, and that's why this thing works, because you know your radio wave travels at about that speed. Okay, so you remember that. Now, let us get into chapter 6. What we're going to be talking about, a little bit about band plans. Making contact using repeaters, nets, satellites, that's cool. Band plans, when we talk about band plans, a lot of time what you're thinking about okay. Oh, share screen. Okay, when we're talking about band plans, a lot of times what you think about is the more high level chart that shows what the operator privileges are in each of the amateur bands. But a band plan, so for instance, the 2-meter band we have here, the 2 meters, about 144 megahertz, right? And we know that the first 100 kilohertz is really kind of devoted to Morse code, CW. But then all the rest of that is phone. And when we say phone, what we're talking about is voice. And in the 2-meter band, the phone you're going to use is mostly FM, although there is single sideband in the 2-meter band also. But you can also use data modes, including RTTY and FT8 and whatever, JT65, whatever, all kinds of, but through the whole band. But the band plan is really quite a bit more than this. And I liked that the book actually printed the table. They printed the table for the 2-meter band. Now, the one thing you have to remember about the band plan is the band plan is a voluntary agreement from hams. And the interesting thing to know about this, all right, so first off, it's not regulation. It's a voluntary plan that we use out of courtesy, really. In the 2-meter band, the band plan is very, very important, because in the 2-meter band, there's lots and lots of repeaters. And as you know, and as we'll talk about later on, repeaters use 2 sets of frequencies. There's a set of frequencies for transmitting, and a set of frequencies for receiving. Okay, now you notice one of the set aside slots for repeater output, meaning, and by output we say this is where you listen. Okay, 146.61 to 146. All right, you don't need to actually memorize those numbers, but for instruction purposes, I want you to see that, because that's where, listening to repeaters in the 2-meter band And let me refer specifically to the Hazel Park repeater, because our repeater, you listen at 146.640 megahertz. All right, that's where you listen. But every time you hit your push to talk, you need your transceiver set up so that it switches down to the input frequency. The input frequency meaning the frequency you need to transmit to the repeater. And it's normal for the 2-meter band that the offset is going to be 600 kilohertz. So for instance, and let me see if I can do this. If you can see, let me see if I can do this. Okay, can you guys see my radio?
Yep.
Okay, now can you see the frequency I'm on? I don't.
146, 640.
Okay, now when I press the microphone, all right. When I key the microphone, can you see how the frequency changes?
Negative 600 offset, right?
Yep. Yep. Because you see it went from 146.64 to 146.040. Let's get back in there. All right. I just, it's a little cumbersome to show you that kind of thing, but still. All right. So in the 2-meter band, there's an offset of 600. When you get to the higher ranges, sometimes it's not minus 600, sometimes it's plus 600. So you see this repeater inputs down here at 146.01, but if you look up at 147.60, you see there are also repeater inputs. So some repeaters, so you have to know what the moral of the story is. You have to know the correct offset frequency, the correct offset. Okay. Band plans continued. HF bands, back down below 30 megahertz, there are not as many repeaters. The 10-meter band has some, but I think that's about it. So their band plans are much simpler. There are some areas set aside in some bands for beacons, and a beacon is just a transmitter out somewhere that is continuously broadcasting a signal, and it's broadcasting a signal. So if you can hear it, you know that the transmission path to that, whatever part of the world that is in, is open, and you should be able to communicate with people out there. You can go on the internet and find a list of beacons, and let me tell you, there are thousands of them. so it takes some work going through them, but that's what a beacon is. A beacon is just a transmitter that's continuously transmitting, that's making continuous transmissions so that you can tell if the propagation path is open to that location. All right. There's parts set aside in each of the bands for weak signal, and weak signal means, when you're transmitting, normally you're transmitting something like digital. All right, normally digital, where you're getting a lot of distance out of very low power. It can also be single sideband. There's a section of the 2-meter band that's set aside for single sideband, or where single sideband is normally used. And also, well, I showed you there is a Morse code area in the 2-meter band also. That's common. Okay, and then there's areas for satellite uplink and downlink. Now, these are in almost all in VHF and UHF. The interesting thing about this, and there's, if you read your chapter, you know, they went into quite a bit of talk about satellites and whatnot. Not a lot of people work satellites, at least at first, but they talk about that in the technician band because normally the way you communicate with satellites is through VHF and UHF, which your technician license gives you privilege to work. Okay. Oh, and then simplex. Hey, when we're talking about transmitting or working on a repeater, when we're talking about working on a repeater and we're talking about transmitting on one frequency but listening on a different frequency, that's referred to as duplex. Okay, but if you're just making plain old contacts with someone, not through a repeater, you're transmitting and then receiving on the same frequency, that's referred to as simplex. Okay, so remember those two words, simplex and duplex. There is at least one question in your test that they could hit you with. So just remember those. Let's see. Oh, we've already talked about that. Oh, yeah. They make a deal about this. Look, you can read a chart. Okay, so you know, yeah, the red is Ridian data, the green is phone voice, and read the rest. I don't know why they make a deal of that. The heck with it. Okay. And then interpreting the band plan. And you know what, I wish they had done this in the 2-meter band instead of the 40-meter band. In the 40-meter band, you don't have a lot of, as a technician at least, you will not have a lot of operating territory because you don't have much allocation. In fact, all you have is this little bitty 100 kilohertz between 7.025 and 7.125, and you're only allowed Morse code. Okay. So that's, not terribly interesting, but that's the 40-meter band. Morse code, you're going to have a section in many of the high frequency bands. And of course, once you get to VHF, once you get above 30 megahertz, you can do Morse code, CW as it's called. You can do CW and single sideband in some part of every band above 30 megahertz. Okay. Yes. They're just pointing out that reading that's what these things refer to. So this band is just for the extra class, and this is just for the advanced. Advanced, they don't give that license class anymore. But there are a number of people who do hold an advanced license. And they're grandfathered in, and they'll have it as long as they want. And then, of course, there's a general license. And then there's novice and technician. The novice license is no longer being issued either. The technician license is. It's kind of funny, but the technician license is higher and has more allocations than the novice. The novice, they haven't issued those, or they stopped issuing those, I think 15 years ago or 20 years ago. But there are still some out there. In fact, Jerry, you and I had, I think it was in 2019, we had a guy in our tech class who wanted to get his tech license, but he had a novice license for about 20 years or something. And that was funny. It was the only one that I've had.
Right.
Jerry may have had more, but I just thought that was so odd. He was so many years just as a novice. It's like, geez. Back with the old novice license, you used to have to take a Morse code test too. You don't anymore.
Right. And well, the old novice also had some voice privileges that were eventually taken away.
Okay. All right, making contacts. Look, this is all easy stuff, but you can have questions on this on the exam, and that's wonderful because you know what? Out of those 35 questions, you want some easy questions. All right. So what do you do before you make a contact? And the first thing is make sure you're in a frequency that you're authorized to use. All right, and make sure that you know the actual frequency you choose. Your entire bandwidth of your transmission is going to be within the area that you're allowed to use. Okay, so the first thing, make sure you're in an authorized frequency area. Secondly, and the second part is just manners. Okay, first off, don't jump on any of someone else's transmission or someone else's conversations. You know, listen, make sure that no one else is using the repeater at that time on the frequency that you're trying to broadcast. And you do that just by listening. And then it's really kind of polite to then ask, you know, if it sounds like no one's using the repeater, ask, is anyone using this frequency? And you do that because sometimes, and you'll find that this will happen pretty regularly, sometimes you may hear some guy talking and he, you know, speaks a couple sentences and then he goes quiet and then you hear nothing. And then shortly later, he comes back on and sounds like he's answering a question that you didn't hear anyone ask. And all that means is that the other station is beyond your radio range. So you're only hearing the guy closer to you. So that's why you ask, is anyone using this frequency? Because, you know, it could be some guy who you can't hear is using that frequency. And, you know, and if you're on an HT, if you're on a handheld, but he's on a nice mobile station and has a nice antenna, although you might not be able to hear him right away, he may be able to get back to you. Or the guy he's talking to you can get back to you and say, yeah, we're busy. And when that happens, you just say, okay, sorry, N8 REL clear, and then switch frequencies.
I own this frequency.
Every now and then you'll run into some jerk who thinks he owns the frequency, but no, we don't own the frequency, and we need a little courtesy with each other, and that's, you know, a little courtesy goes a long way. I found usually hams are pretty good, and I find this even in contests where people are trying to make lots of contacts very quick, and so the transmissions are very, very short. And every now and then a newbie gets on and has to be talked through the process. And I find that when that happens, the person is usually treated with some courtesy and some patience. And gee, wouldn't it be good if we all practice that in our daily lives? But please practice it on the radio. Okay, what if you receive a report that your signal is strong but distorted? Well, okay, like Jerry said earlier, it can happen that you're talking and you just bump your little tuner knob and you've knocked yourself off the frequency just a little bit, you know, just a couple of kilohertz. So it may still get through, but may not get through well. Okay, so you may be off frequency a little bit. Also, and Jerry talked about this also, is that if you're speaking too loud and what's called over deviating or over modulating, that can give you a very, very distorted signal on the other end. On the 2-meter band, remember, that's a very short wavelength, and moving from one position to another can change both your transmission and your reception. So, especially if you're on a handheld and you're having, you know, problems hearing or transmitting, moving just a couple of wavelengths. And remember, when we're talking about the 2-meter band, a wavelength is about 6.5 feet. So moving 6.5 feet can make a difference. Now, if you're on the 80-meter band, when a wavelength is, 240 feet, well, even more than 240 feet, then yeah, it's not so sensitive. Okay, and of course, weak and low batteries will also mess things up for you. Repeaters add a short courtesy beep. I don't know why they bother with this, but yes.
Bob, as far as courtesy beeps, there's a purpose for that. The timer,
Sorry?
the timer.
Oh, the timer. The timer, yeah. Well, on repeaters, you're often limited to no more than about 3 minutes. And what happens there is if you go past 3 minutes on a repeater, you're all of a sudden not sending out a signal to anyone because the repeater, cuts you off. And we get that on our Sunday night 2-meter net. In fact, we've got one guy who comes in all the time, an experienced extra class guy who blows through the repeater timer regularly. In fact, we refer to him as Timeout Jim. So that's what that's for. All right.
And the problem is on your end, you don't know it.
Yeah.
If you get timed out, there's nothing telling you you're timed out. You're keyed up and you're just babbling on blank space.
Yeah.
So
Well,
be aware of that.
Yeah, the only good it does you though is you want to, when it's your turn to transmit, you want to wait for that courtesy beep so you know the timer's starting again. Otherwise, you're going to go on the tail end of the other guy's transmission and get cut off sooner.
Yeah. So you don't get your full 3 minutes of babble. Okay. All right. Simplex channels. We talked about that. Is simplex is simply, you're transmitting and receiving on the same frequency. And, you really, if you're talking to someone nearby, within a few miles, it's best to use simplex just because you don't want to use up the repeater, to lock up the repeater for people who want to make long distance transmissions or long distance contacts. So yeah, use simplex as much as you can. And now they talk about reverse split function, which I kind of wish they had in a little different section here. But what this just means is, if you have your transceiver set up for repeaters, and you're transmitting on one frequency and listening on the other frequency, you can actually use this reverse function, and what it's going to do is it's going to let you listen on the transmit frequency. And what that's good for is if the person who's transmitting, trying to talk to you, is somehow not hitting the repeater quite well enough, you can hear his input rather than relying on hearing the repeater recycle his transmission. Okay. All right.
Sometimes you can talk to the guy direct without using the repeater.
Yeah. Yeah. Okay. All right. Now, national simplex calling frequency. Say it's a nice Saturday morning. You want to, make a contact on 2 meters. You don't have anything prearranged with anyone. You can switch to this 146.52 megahertz. And this is a frequency where people often go to find contacts, all right, to find someone to chat with. it's kind of nice. It's kind of like a watering hole. And this is and guys, this is something I'm just going to have to ask you to memorize, because this can also be a question on your exam. They can ask you, what's the calling frequency, or what's the frequency on simplex 2 meters for the national calling frequency, and it's just 146.52. This is one of those things. It was easy for me, because it's going to be in the 100 and the 2 meter band. It's going to be in the 144 to 148. Well, okay, 146 isn't that hard to remember. 52. When I played football in high school, that was my jersey number, and so it was easy for me to remember that. But for the rest of you, just
It is definitely on the practice exams I have been taking.
okay, yeah, yeah. On 70 centimeters, the calling frequency is 446. I don't remember if that's, I just don't remember if that's a question. But I don't think it is actually, but the 146.52 definitely can show up. Okay, making contacts. How are we doing on time? We're doing okay. Starting contacts. Yeah, this is real easy. Now, these some of these codes are used. They really came out of Morse code, but there's a code called CQ, and it just means I'm calling any station. I want to talk to anyone. Think of it as like the two words seek you, and that's what that's all about. And so a transmission on that, you get up in the morning, you want to talk to anyone, you want to make any kind of contact, and you just call CQ, CQ, CQ. This is November 8, Romeo Echo Lima calling CQ, and wait for someone to respond. You can also do that, of course, on Morse code. CQ, 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 DE. DE. I think people say it's from French, but we all know it's from Spanish. meaning from. Okay, and then your call signed. All right. Oh, before you call CQ, 3 things. Yes, make sure you're in the right frequency range that you're authorized to use. Yes, make sure the frequency is not already in use. Yes, make a short transmission asking, is the frequency in use?
Now, if
Hello,
you're
this is
HM,
N8REL. Is this frequency in use? This is N8REL. And wait for a response. And if there isn't, go for it. Okay.
yeah, Bob, as you were talking a little while ago, if you're on the 10 meter band, what you're authorized for with your technician license, 10 meter has skip. And sometimes a station nearby will skip over you, so you won't be able to hear him, but you might be able to hear the guy he's talking to.
Yeah. That comes from the whole subject matter of propagation, which I think is just fascinating. I just think it's so cool. Okay, responding to a CQ. So if I'm calling CQ, 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 this is N8REL, November 8, Romeo Echo Lima, a response might be, Jerry, how would you respond?
What, no, it's N8REL, this is W9NPI, Whiskey 9 November Papa India.
And that's it. It's that simple. And oh, by the way, and that can be another one of those beautiful, easy questions that show up on your technician license exam.
That has shown up on practice exams, how to answer CQ.
Yeah. Okay, Q signals. Q signals they're kind of interesting. And there's a whole table of them in Where is? Huh. Hang on just a sec. I'll be right back. Okay, there we go. Okay, now let me stop sharing that. There. Okay, am I sharing?
Not
No,
yet.
not yet. You were a second ago, but it went away again.
Okay, hang on. Let's try it this. How about now?
Yep.
Okay. There's lots of signals and lots of Q signals. However, here are the three I want you to absolutely remember. There's two Q signals that deal with interference. One is QRM, one is QRN. Okay, QRM, Quebec Romeo Mike, QRM, that is interference when the interference is man-made, which would be like another operator who's messing something up. All right, QRM. QRN, Quebec Romeo November, that's when the interference is natural. And this would be like static in the atmosphere, static from thunderstorms or something like that. So the difference here, one is man-made, one is natural. So when you see QRM, I want you to think man-made. When you see QRN, I want you to think natural interference. Okay? Quirm and quern. Okay.
Excuse me, Bob. Quick question. Could you please provide a quick example of how these would actually be used? I mean, so I'm communicating with another operator. Who says QRM and in what context? Like, how would that actually work?
Well, this would be like you hear something and you would just announce, hey, I'm getting QRM from, if you know the guy's call sign, and this would be, like if someone is, talking over your previously in process conversation with someone else.
Bob, I'm getting some QRM right now. Why don't we QSY up 5?
Okay.
Got it. Thanks, guys.
Okay. Yeah. Now the QRN, there's not much you can do about that unless you've got real connections upstairs. Okay.
Well, there are some anti-noise, anti-QRN circuits in most modern radios. Noise blankers, and I have a noise eliminator that seems to do very nicely on taking out a lot of static. Of course, if you're expecting a thunderstorm, you're going to get an awful lot of stuff, and you shouldn't be on anyway if these.
That's right. Okay. So QRM, QRN, know those. Also know QSY, and that just means, this is something. Well, like Jerry just demonstrated, you're on a frequency, and there's too much interference on it, and you want to continue your conversation, so you're going to change frequencies, and so you would say something like, "This is N8REL. I'm going to QSY plus 5 kilohertz." Or plus 600 kilohertz or something, So it's telling someone you're going to change frequency or asking them to change frequency. But okay, those three you need to know: QRM, QRN, and QSY. Those could appear. Now there's a couple other very handy ones that you probably you'll get to know. But this QRP, this decreased power, there's an activity where some hams like to see how far they can go with as little power as possible. So QRP operating usually refers to operating with with 5 watts or less. And if you're using now, I mean, if you got a really good antenna system and you're using Morse code or a digital code, you'd be surprised. You can get some distance with that with just 5 watts. If you're doing FM, the FM voice, no, it's not going to work. Okay, QSL, you'll get to know that one too, and that just means you're acknowledging you've heard a transmission. There is something called QSL cards, which I think they come up in another chapter. Someone else will talk about that.
Yeah, but QSL also means yes, like a guy tells you your signal report. I'm Jerry in Oak Park, Michigan. Okay, back to you. And then Bob would say, QSL, Jerry, I received it.
Okay. QSO is often refers to a communication or a conversation, or a contact. You can say, like if I had a QSO with Jerry, meaning, we contacted and it was good. QTH is another one that you'll hear a lot, which just means your location. All right, your QTH, where your station is located. Okay. A lot of these others, QST, you'll hear a lot because that's the name of the ARRL's monthly journal. But a lot of the rest of these, you'll never hear about them. So,
well, wait, QST. From time to time, if you look at the QST magazine, there's a schedule. But from time to time, you'll hear official bulletins from the ARRL. The FCC allows them to broadcast these announcements, and they usually start their transmissions by saying QST, this is W1AW or whatever station, and then they'll tell you what's going on. There might be a solar flare coming up or something like that.
okay.
Also in making contacts, QSOs or QSOs, some of the younger guys are starting to shorten that. Oh, I made 100 Qs in the last contest.
Oh, well. Yeah, you know what? It's like, really, you can't come up with the other 2 letters. It just drives me crazy, when people talk about vacays. They went on a vacation. Come on, it's one more syllable, for God's sakes. Anyhow, that's what Q signals are all about. DXing. Yeah, when we use the term DX, what we're talking about is just talking to a distant station. Okay. Yes, and in the HF bands, that could be thousands of miles, or some people use it to refer to simply foreign stations outside the US. On VHF and UHF, DX is a matter of dozens or tens of miles, simply because you're not bouncing your radio wave off the ionosphere, so you line of sight. The horizon, the visual horizon, is only about 3.5 miles. The radio horizon goes on VHF and UHF goes a bit beyond that, but not that much, and is dependent on how high the antenna is and what objects are in the way. Okay, contesting is simply a set period of time where people are trying to make as many contacts as possible. Contests can be voice contests. They can be limited to different modes. There can be CW Morse code contacts. there,
radio teletype and
there are RTTY contests.
absolutely. I remember operating on 40 meters CW. All of a sudden, all the CW stations were being taken over by teletype stations.
Oh, okay.
I even sent a complaint to the to QST, and they told me to just chill it.
Change frequencies. All right. All right. Contests can be they sometimes start, like on Saturday during the afternoon and go all the way till Sunday afternoon. Sometimes they're longer than that. There are short contests that are only a period of a couple hours. Those are referred to as sprints. It's an interesting thing to know. I don't think there's a question on that though on your exam. Okay. For those of you who want to look up at contests on the American Radio Relay League's website, they have a contest calendar, and we'll give you everything you need to know. Field day, we've talked about field day before. That's just when we take our equipment out to a park or something and try and make as many contacts as we can. That's fun, and our club does that. It's like the last full weekend in June, so the weather is not always, but usually nice. We've been rained on sometimes, and we set up tents and set up our equipment and see what we can do. This is a great thing, and I hope when you get your tech license, you come out, because when we have those radios set up, there's going to be, even you with your tech license, we will have extras, general licensees and extra licensees. And when we're there with you, you can transmit on our frequencies. So, oh yeah, do that.
All right, even without a license, people can operate. We welcome the public.
Yeah. We also have one transmitter usually set aside, one transceiver set aside for what you call a GOTA station. GOTA, get on the air. So. Yeah, and people of all ages and no license whatsoever can come. All right, then there's this activity called fox hunting, and really all that is it's a kind of a game, and someone hides a transmitter, acting like a beacon, sending out continuous transmissions, and with small directional antennas, you try and find that thing. Now, the kind of antennas you'd use again are directional. This would be an activity normally done, either in the 2-meter band or somewhere in UHF. And so the antennas involved are quite small, and you need directional antennas, because an omnidirectional antenna, yeah, you could pick up the signal, but you wouldn't know what direction it's coming from. But with a directional antenna, you move your antenna around till you get the loudest transmission, and that's the direction your transmitter is located. Okay.
I'll tell you, young Jerry, back in the 1960s, 50s and 60s, would go on fox hunts, and we were trying to find. The eventuality was that some guy would hide a transmitter in his closet, turn it on, and guide the Russian bombers into our fair city. So we were actually looking for trouble.
Oh, the fun days of the Cold War.
What is a common form factor for a Yagi antenna? Is it like a dish antenna?
No.
No,
It's more like this.
It's three.
This is a big version of one, but it would be a smaller version of this, where you have a beam, a center beam, and then you have elements that focus the radio wave in. There would be a connector here.
That's the driven element.
That's the driven element. The connector here would connect to coax and would hook to your transceiver, which in fox hunting, it'd be a much smaller antenna, and you would hook it to your handheld. So you could actually,
Wow.
you know,
And so, and is this, now I'm started remembering this antenna. Are the signal direction, going back to the donut we talked about, is it going off to the sides of this particular type or off to the front like a rifle or something?
off to the front like a rifle.
Okay.
Yeah, there's one reflector, and then the others are called directors.
Yeah.
They focus the beam like a magnifying glass.
So when you point it at something and your signal intensifies, it's, you know, like a metal detector or something, right? Okay.
Well,
Yeah.
if you point it at, if you're at one location, you point it and you find the maximum strength, then you change your location, point it again, and you can triangulate, zero in on the guy.
That sounds like a lot of fun. Thanks.
Yeah, and now when we say, now remember though, I'm pointing based on the beam, not on the elements. The elements are horizontal, so it's still, you know, you're dealing with going off the broadside and receiving from the broadside, not from the ends.
And one more follow-up question, going to the safety section and thinking about RF burns and being too close to proximity of a transmitting antenna on the VHF and UHF, it sounds like that's not really a concern. It's such low power.
No,
Nope.
Such high frequency.
it's the frequency as well as the power. Actually, the area, Bob, is it what, 30 to 300 megahertz or thereabouts? That's you have the most. Well,
Yes, VHF, you have the most. But remember, when you're doing fox hunting and things like that, what you're working with is a handheld. You know, you don't have a you don't have your big mobile radio with it. Your handheld's only 5 watts max. And in fox hunting, remember, mostly what you're doing is you're receiving, you're not transmitting. So when you're not transmitting, zero danger. Okay.
Thank you.
The only danger is, you know, poking yourself in the eye with the end of the antenna. Okay, so that's that. And radio direction finding. Oh, yeah, the FCC can do that if you're a really, really bad person. They come looking for you. Okay, video. And I don't, well, okay. I don't use video at all on amateur radio. Not at all.
I have software on HF where I can pick up some slow scan TV on 14.23 megahertz, and it's not going to rival Netflix or anything of that sort. It's just
Hal, how was your birthday party?
It was great. Thank you. Yeah, so
Okay.
I calculated how many times your son turns, my only son turns 31 and it's only once. So I had to, I apologize. Your group means so much to me. So thank you very much.
Okay. Oh yeah. Grandchildren yet?
Yeah, 2 grandchildren
All righty.
from the daughter.
Oh, okay. All right. TV. All right. Here's something I want you to know. This NTSC, because there's actually a question on this, and you know, I don't know why. Anyhow, this National Television System Committee standard. This is a standard for sending fast scan color television signals. Now, in this day and age, this is analog. This is analog fast scan color television signals. And this is the protocol you need to use, this NTSC. Now, the thing is, nowadays, commercial television doesn't really send analog anymore. Commercial television is pretty much all digital signals, but on amateur radio, you can send analog fast scan color television signals through this NTSC protocol. All right. I don't do that, so I don't. But remember NTSC. Remember analog fast scan color television signals. All right. There
So
is
how
also-
does that work if you're not supposed to broadcast with your amateur license?
You are-
Oh, well, you'd be sending that communication to another ham. So it's just like a transmission.
Okay, so it would be like short videos, like sending gifts back and forth to somebody in a text message.
Mhm. Yeah,
Yeah. No, I don't know how long
Okay.
those things can be. I don't think I don't think you can do a TikTok on it or anything, but
okay, so you can send cute puppies and kitties on it, just like you do on TikTok.
So short videos, but so you weren't like broadcasting a TV show, it'd be like a short video clip of something or
yeah.
something like that. Okay.
Yeah, a short personal communication, right. Okay, there is also something called slow scan television, SSTV. This is, I think, down in the HF
Right.
areas, and this is
14.2
HF bands, and it's you can send a single picture. It takes about 8 seconds to materialize on someone's screen. Obviously, this kind of stuff needs a computer to go along with it to show you the visual.
That's still faster than 90s internet was.
Okay, right, 300 baud, yeah. But still you're talking about different strokes for different folks. Some people are thrilled by this, other people are trying to bounce their signals off the moon.
Yeah. Okay, you know what? We've only got a few minutes left, so you know what? I think I will go through these questions. Just rather than start a new topic, I'll just take this time to go through just as good review, because these are the actual questions that can appear on your exam. Okay, so where may single sideband phone be used in the amateur bands above 50 megahertz? And in this case, remember, it's what I said was, oh,
It's
damn it.
C, at least some of
Yeah,
these.
at least in some segments, because above 50 megahertz, again, we're talking about VHF and higher, VHF, UHF, and SHF. Anyhow, in some part of all those bands, you can use single sideband phone as a technician licensee. Okay, what is a band plan beyond the privileges established by the FCC? And when they say beyond the privileges, they're talking about beyond the frequency allocations. All right. And the one thing I want you to remember about band plan is that it's voluntary. It's a voluntary guideline. Okay. It's not a list of operating schedules. No, it's not a list of net frequencies. It's not a plan designed by a club. It's a plan kind of agreed to. Oh, and this is important. It's not, the band plan is not something dictated either by the FCC or by the American Radio Relay League. The American Radio Relay League does publish the guidelines, but they publish it based on how the bands appear to be used. Okay, it's voluntary. And you know what? It does us all good if we follow that. Okay, what term describes an amateur station that is transmitting and receiving on the same frequency?
Simplex.
Yes, simplex. Remember, there's two things I wanted you to remember: simplex and duplex. All right, duplex is through a repeater. Simplex is on the same frequency. And then there's diplex, which I don't think means any. That might be a wrapper. Okay. Or maybe that's Diplo. I don't, at any rate. What is an appropriate way to call another station on a repeater if you don't know the other station's call sign? And just simply Wait a minute. What is an appropriate way to call it another station on a repeater if you know the other station's call sign? Yeah, that makes a lot more sense. I mean, if you don't know the other station's call sign, you're not going to call. Okay, if you know them, what do you do? And yeah, just say the station's call sign. W9MPI, this is November 8, Romeo Echo Lima.
November 8th, Romeo Echo Lima, W9NPI.
Okay, good man.
Yeah, and just let me throw something out there-
QSL.
just to throw something out there real quick, because when I took this class, someone had a really hard time remembering. They wanted to say, I want to say my call sign first, then their call sign. And so the easy way to remember it is, hey, you, this is me.
Right. Yeah. 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 Hey, you.
That's actually helpful. Thank you.
Okay. Which of the following indicates that a station is listening on a repeater and looking for a contact?
Monitoring.
Monitoring. This is all you need. This is N8REL monitoring. And you will hear that regularly on repeaters, you know. And when you hear that, you hear someone monitoring, that's almost the same as saying CQ. They're listening and they want to, you know, contact someone. Okay. What might be a problem if you receive a report that your audio signal through an FM repeater is distorted? All right. Could it be that you're slightly off frequency? Yeah, it could be. Could it be that your batteries are running low? Yeah, that'll cause a world of hurt. And could it be that you're in a bad location? And remember, on FM and VHF, we're talking about very modest wavelengths, and moving just a short distance can get you, can change the characteristics of your communication. So yes, all of those are correct. You know, not many of these questions have responses where all are correct, but this is one of those that is. Yes, you could be off frequency because it's real easy to, you know, fiddling around with your radio to accidentally just bump the tuning knob and get yourself off a few kilohertz. Okay. What's the national calling frequency for FM simplex operations in the 2-meter band?
Hey,
All right, this is one I just need you to remember. It's one of those things. It's not hard, you know, but you need to remember it. So first off, 2-meter band, all of a sudden, you know that the 430 and 440, you know those are wrong. Just plain ass wrong. And the 145.000, no, just remember that that's wrong too. It's not 000. All right, so it is the 146.52. Or of course you could remember, oh yeah, that was the jersey number of that left guard for New Trier High School in 1964.
Bob, I got to tell you, that's how I'm going to remember it.
Okay. What is the VHF UHF transceiver's reverse function used, or how is it used? Yeah, and remember the reverse function is you're going to listen. You know, for the repeater, you know, they've got a listen frequency and a transmit frequency, and normally you listen on the listen frequency, and on VHF the transmit frequency is 600 kilohertz different, and using the reverse function you're going to listen on the input frequency. Okay, how are we doing on time? Oh, we got about another 2 minutes. All right. What are simplex channels designated? Why are simplex channels designated in the VHF UHF band plans? Okay, and remember, in VHF UHF there are lots and lots and lots of repeaters. You get down into the HF area below 30 megahertz, very few repeaters. But in VHF and UHF above 30 megahertz, lots of repeaters. And remember, they need two bands of, or two sets of frequencies, you know, so they take up some space. So, so anyhow, simplex channels are designated so that hams can use frequencies without tying up a repeater and without, you know, messing up repeater operations.
And there are people out there. Some people don't believe in repeaters. And if you just put out a call, W9NPI listening, you're likely to get some kind of an answer.
Okay. Now, how should you respond to a station calling CQ? Very simply. Just transmit the other station's call sign and then your call sign. All right. Hey, you, and here I am. Okay, and what's the meaning of the procedural signal CQ? Well, that's just calling any station. We beat that to death. And what should you do before calling CQ? Yeah, we beat this one to death too. Listen first, make sure you're in a good frequency range, listen and then ask if it's in use. And what's the Q signal that indicates you're receiving interference from other stations? Other stations, that's man-made. Yes, QRM, that's it. And guys, I think we are at 9 o'clock, so we will continue this next week, and I'll finish up, and then and after I finish up, Mike will take over and start into chapter 7. Chapter 7's cool. Chapter 7 is rules and regs, and that, guys, that is stuff you need to know.
Yeah, it's kind of dry, but yeah, it's stuff that you really do need to know. Yeah.
Hey, a couple quick questions. Sorry. When is the next technician test? I thought it was February 7th. Is that correct?
That is correct.
Okay, perfect. And how do I get details of like where to go and stuff like that?
Oh, Oak Park Community Center.
That's a mystery that's shoot me an email. Oh, Kurt, I'll send one to you.
Thank you, sir. And then last question, sorry. The reverse function, when you're listening for the inputs on a repeater, what would be the purpose of that? Why would you do that?
You would do that if you think there's another station you should be hearing, but you're not hearing them through the repeater. You know what the other station's doing? They're sending out a radio transmission, and depending on it, to hit the repeater, for the repeater to receive it and then retransmit it. Now, think about, Kurt, you're in Lake Orion, right?
Yes, sir.
Okay, so let's say you're trying to transmit and you're trying to hit our club repeater down in Oak Park. But you're not hitting it. But I'm in Rochester Hills. I'm only a couple of miles away from you. I may hear your transmission on the transmit frequency. So I can hear your transmission. I don't need for it to hit the repeater and the repeater to hit it back to me. I can hear it like it's a simplex transmission.
Okay, got it. Thank you.
Sure. Okay. Let me stop sharing. And I'm at 9:01. Guys, thank you very much. This was fun tonight. And let's go at it again next week. Same bat time, same bat channel.
Thank you very much, guys.
Thank you.
Yes, thank you.
Have a good night, fellas.
Good night, guys. Bob, I forgot to punch my record button. I'm sorry to say.
Oh, okay.